Ta-da! We're live. Hopefully. All right. So we just had a rousing discussion over on our Stellar Turrets Discord about actually running turrets, particularly production level turrets on the public Stellar network. And now we are transitioning to, okay, turrets are great, but I actually want to build smart contracts and get them uploaded to turrets so I can get in on this this Stellar smart contracts nonsense that everybody's talking about. Well, you're in the right place. We're going to cover all this. Probably not all of it. So I take that back. We're going to go through the API for turrets. We're going to build a simple smart contract, get it uploaded, show you kind of all the moving pieces. It's going to feel a bit overwhelming, like, oh my goodness, there's so many moving pieces. Understand that we're in a very early stage, so it's like this really low level. You're touching like the turrets API itself. In the future, there will be interfaces that'll make this easier. I think there's already this sort of no-code turrets interaction interface GUI. So there'll be methods to make this upload process easier. There's not a ton of endpoints. The biggest challenge will be that you have to kind of replicate. If you want to get decentralization, you have to upload your contract to multiple turrets and add those signing keys to your control account. So I've already started using terminology that I shouldn't assume you already know. So let's kind of start with kind of just a really basic overview of turrets. I'm sure I will say things that you're already maybe unfamiliar with. So as you have questions in our Stellar Turrets Discord, there's a channel called Live Chat. So you can ask questions there, or you can ask questions here on the stream. So feel free to do that. I'm going to make a quick announcement here on this Discord, just with this link here. Make sure everybody's in. We'll give it a couple more minutes while we get folks in. And we'll get cracking. But again, if you have questions, either in the Discord live chat channel or here in the Twitch chat. But I'm just going to dive into it. I'm going to go ahead and share my screen so that you have something to look at besides my beautiful face. So when you're building, with Stellar Smart Contracts, there's really only one thing that we're tackling. Well, two, but there's really, in a smart contract, there's two things you want to do. You want transaction execution, so the transaction actually makes it on the blockchain, and transaction creation. Stellar has decentralized transaction execution, right? When you push a transaction to Stellar, you post that XDR, it will tell you whether or not it can make it based off the current state of the ledger. That's super. That's great. That's the whole point of blockchain. But there is this other side of transaction execution, of how do we get a transaction made? How do we build it? Currently, the thinking is, or the method is, that you do that always centralized. You have a single server or your service that generates XDRs for your users, and they just hope that your service will always be up to fulfill whatever promise you've made that your service will provide. I think that transaction construction is actually also really important to do in a decentralized way. And that's the whole point of DeFi, is that these services and capabilities shouldn't be limited or controlled by single sources. They should be decentralized, where a multitude of machines are needed to perform the actual action, and just by removing one machine, you haven't actually shut anything down or turned anything off. So you kind of get what Stellar does for execution, for creation of transactions. The issue is that just because you create a transaction in a decentralized way doesn't mean that it's executable. You also need to get it signed, right? I can find your public key and make a transaction that says, give me all your money. But unless I get it signed, it's useless. It doesn't actually accomplish anything. So we need both transaction creation, but also transaction signing, so that the transactions we create in a decentralized way actually have sufficient signing weight over whatever account is in question, whatever payment you're trying to make, or managed data attributes you're trying to add, or NFT you're trying to mint, that can actually get published onto the blockchain where it modifies the state of the ledger. So that's what turrets do. That's what Stellar turrets do. They decentralize, or allow you to decentralize, the creation of Stellar transactions and the signing of those Stellar transactions such that it actually does something useful. That really is it at the core. The nice thing is that there isn't like a Stellar turret network that you upload contracts to. You get to decide what your decentralization model is through the multi-sig setup. When you upload a contract to a turret, it sends you back a signing key. You upload it to another, it sends you back a different signing key. You upload it to 5, you get 5 different signing keys, so that when you call the endpoint for the contract that you just uploaded, it'll give you an XDR and the signature for that XDR to actually get submitted to the blockchain. But for the control account that you're involving your smart contract with, your XDR with, so you're trying to make a payment from an account, if you actually want that to go through onto the blockchain, you get to decide how many signatures from turrets that you need, or if you maybe still need your signature, right? You can use the weights and thresholds on a Stellar account to configure your own decentralized network. So it can be as tight-knit or as open as you want it to be by adding a 5 of 10. So you've got 5 weights and a threshold, or you've got 10 signatures with a weight of 1 and a threshold of 5. So you're getting at least 5 weights, 5 signers, to be able to equal the threshold of 5 for whatever operation you might be trying to submit. And we'll get into that a little bit once I actually start adding these signers to an account. But the first thing that we probably should do is actually start building a contract. Now, the really nice thing about this is that because you get to create your own decentralized layer, like you're building first centralized. You're just building a JavaScript function that creates an XDR. That's all you're doing. And then you add, the way you get decentralization is by adding that function to multiple computers that all produce the same XDR. You combine the signatures together, and now it can go to the blockchain. Now it can be verified on the chain, on the ledger, and change its state. But when you're designing it, when you're initially building your smart contract, you don't have to be like constantly uploading it and hoping that everybody coordinates the same. You can just jump into RunKit or your VS Code editor and just build a very simple create an XDR function with some basic inputs, and walla poof, you get a smart contract that can now be uploaded to the turret. So let's start there. I have a inside, so I'm in this repo over here. Stellar turrets inside my Thai VDH GitHub account. And I think there's actually some contracts. There's a really basic TX function right here. Actually, I think this one may be on pointing to a RunKit. So let's use this raw one right here. And I'm doing all this live. I didn't practice this beforehand, so we might get into the weeds a little bit. So bear with me. But let's just go ahead and copy this over to, let's just make a new RunKit notebook. I'm gonna copy those out. So there's actually a couple of modules when you're building these contracts, because there's a few. The contracts actually run, so they execute right now in my reference implementation here. Stellar turrets, which probably worth mentioning. Stellar turrets is actually just a protocol. This repo is the reference implementation, where we're kind of using this reference implementation to design the protocol, but this is just a reference implementation. So there's certain endpoints and certain responses that are expected, but it's a protocol that's being designed, and then this reference implementation is kind of following that. And in this model, the actual execution of the contract is happening on an AWS Lambda, so a serverless function that's really locked down, isolated from any other secrets, with a really restricted memory consumption and time bound, so it can't just run forever. And in this, I've set up a few packages, NPM packages, that you get for free. So if we look at our serverless, They're included right here. So these are the ones you get for free. So when you actually build a smart contract, it's a single executable JavaScript file. So if you're including NPM packages that are not in this list, you're going to have to use like Webpack or something to bundle those into the final JS executable. Otherwise, you can leave them out. And you can just require these, and then in your Webpack say ignore the require or assume that these are already included if you're using any one of these. So obviously this one is the one we'll make the most use of. So if I do const, and then we'll grab this, equals require the Stellar SDK, and then we're going to use this. So this particular contract is a little bit outdated. We used to do this a little bit differently, where we used global variables to include the packages, but we've switched to where you can just do the require and then use Webpack to ignore any modules that have already been default included in the AWS runner. And then we have this piece which comes in as the argument. So when we're actually calling our contract, we can pass it arguments. So a contract is just going to be an API endpoint that you call for the contract hash, and then in the body, the JSON body of the request, you can pass it arguments. So in this case, it's taking an argument of a source and a destination. So cool. I actually don't know if we log module.exports, does that work? Looks like maybe it does. If I call module exports with an argument, with a source and a destination. Curious what source is actually doing here. Let's look through our code. We are calling the source, loading in an account ID and an account sequence. Looks like we're making a payment from the source for 1 lumen back to the destination account. So the source account in this case is going to be what we call our control account. So every turret is going to have at least one controlled account. So this is the account that you're trying to decentralize ownership over or usage over. You want the internet to be able to use this account, but you can't give them the secret key because then they could steal all the money, merge the account away, do all kinds of stuff with your account that you don't want them to do. So this is like the whole point of turrets, again, is to like safely give ownership of an account, but they can only use it as per the contract. So in this case, the source account is going to be paying the destination account 1 lumen, 1 native asset, every time that this contract is called. It's going to build an XDR that pays out 1 lumen to the destination account from the source account. So the source account is going to be our control account. So I'm going to go over to laboratory and actually just spin up a couple of new accounts. This one's going to be our source, right? The control account, the account that we want to give the internet control over, but only through this smart contract, right? And this one's going to be like our user account. This would be the key maybe you get from Albedo or Lobster or something. This is the user that's trying to get, in this case, this 1 lumen. They're trying to get something from the control account. And these arguments, again, like you can pass anything you want. In this case, I'm just a source and destination. It could be arrays or a whole nother XDR, an whole nother transaction or transaction sequence number. I don't know. You could do anything you want. An IP address. But anyway, I'm still testing to see if I can actually call a module exports right here. So the source account, again, this is the control account that we want to give 1 lumen to this account, right? So I don't want anybody to be able to take more than 1 lumen in this case. So I'm using Stellar Turrets to accomplish this, but I also want them to always be able to take 1 lumen from this account. And I don't decide, oh, you know what, today I'm going to shut this whole thing down and I'm going to shut my server down and nobody gets any lumens from me today. I'm giving this to the turrets network such that I don't control the machines that the TX function is running on, so I can't remove it. We haven't gotten there yet. Let's actually see if this generates the XDR that we expect it to. This might, I don't know what this will spit out actually. This might not spit out anything because it would need a promise. There may be... Fetch is not defined. I actually want to use the server, so I'm using fetch right now, which we could definitely use if we just called fetch. I think fetch is in a weird state right now if I didn't pin it to the older version. But we're just loading in an account right here, so we can actually use the server from the Stellar SDK, which I'll just include this outside of here. Const server equals new server. We're going to do the testnet for now. You'd probably want to make this a variable that gets passed in, which actually there are also 2 global variables that are made available to this runner. And those are the Horizon URL and the Stellar network. So these would be global variables that are available that have been set by the turret. So depending on what turret you're running on, they may have a custom Horizon that they're running, or they may be on the testnet or the public network on Stellar. So you can use these variables inside of your contracts rather than hard coding those or including it in the arguments. You could include it as an argument, right? So you would pass it into the body here. But why not grab it from the turret? Which, let's go ahead and look at one of these turrets. Here's my testnet turret over here on Postman. So if I run this, you can see what those would be. The network here is testnet, and the Horizon URL is this testnet. So we could use those. In fact, let's go ahead and do. I would have to remove them. So like when you're designing your contract, I would just have to remember to remove them, because I could set up a global variable here and do Horizon URL and Stellar network. So like in your Webpack, you might want to remove these or just include them as global variables that Webpack makes available to the code without actually hard coding them. Because then you would do this for our example and this. So I'm actually going to put these above here so I remember to not include those in the final file upload, and then we would do this, and then whenever we get to our network we'll include this, and then we just won't include these because those will be available to us at runtime when the contract is running on that AWS Lambda. All right, so now we've got our server, so we can do server. Looks like RunKit does 4 indents, or they have made a statement. They are not a 2-space. Just going to make my code different because I am not that way. I'm just going to run this for now. Load account. This one. Then the account is available. And so we don't need any of this anymore. We just need this. And I should return this. Going to make this so I can see this one is actually the account, so we can just pass that. Clean this up just a little bit. Base fee, which you might want to make that dynamic so it's not hard coded to what the base fee is right now, 100, because that public network in particular can vary a lot. So there's a couple of nice endpoints here where we would include that global variable. Native timeout is 0. That's actually kind of important because if we do timeouts here, it might be different if we were to upload this to multiple turrets. This time could be different, and if your XDR is ever different, the signatures will not be able to be added together. I'm going to go and do a then statement. Actually, can we do a wait and have it spit out the result? but maybe not. Oh, I need to return the XDR. There we go. Sweet. So that would be our XDR, right? So if we were to look this up in our XDR viewer, it should be that the source account, this destination account, is paying the source account is paying the destination account 1 lumen. So that's our contract. Obviously, you're going to get way more complicated with all kinds of different things. I've got my, if you guys followed the NFT drop that I did not long ago, this is the contract for that. Again, looks super similar. You got your module exports, the body, pulling out a source from the body. That's the thing that you include. You can see my server that I'm setting up here with that Horizon URL. Lots of nice, nifty things, but it's just this building a Stellar transaction based off of the inputs. We're making some calls to the server here for some information from Horizon, but looks pretty similar to the one we've got here. So we've got our contract. Now we need to get this uploaded to a turret, and the only piece that we actually need is this, right? Because this is testing information to actually try and run it, and this piece is the global variables that we kind of stubbed in, if you will. So I'm going to take this, go to my VS Code editor. Can I make a... I should need to figure out how to make a new window. There we go. Okay, so I'm just going to review, make sure this all looks good. You could run this through Webpack. I don't think there's any need to. It's not going to get a whole lot smaller. I'm requiring the Stellar SDK, which is already going to be included. Looks like I'm not using account anymore, so I can get rid of that. The server's outside. I think that's all good. We already tried to run it and it worked. We're going to be running on whatever the network is that we upload the contract to, pulling from Stellar Network and the Horizon URL. So I think this looks good. So I'm going to save this to my desktop. I'm just going to call it txfunkeasy.js and put that in my desktop. So there is our smart contract. The next thing we need to do is obviously upload it to the turret, because if you try and run this or submit this, right, that's not going to do anything because we don't have any authentication. And you might be thinking, well, all we need to do is sign it with the user account, because the users actually, you don't need to sign with the user because the user doesn't need the signature at all, because the only operation is a payment. So we really need the signature of the source account to be able to make this payment. And so that's what the turrets network is for, is when we upload it, we're going to get a signer that we can add to this account to actually gain control over this account through that smart contract. So that's what we're going to do over on Postman. We need to go to our TX function upload. We need to pick our file here. txfunkeasy. Now, what's the TX function fields? This looks like gibberish. That's just a base 64 encoded array of fields. So in this case, we've got two fields, a source and a destination. So we need to build a simple array. I'm actually going to decode this really quick so you can see what this is. I kind of made this a little small. Sorry about that. So let's do A to B. Take this base 64 and decode that into its array, which I guess we can actually do JSON parse on that decode. And then we get our array, which is just a simple object including 4 keys that give some information about the accepted fields for this contract. So like what the body should be made up of to give the contract the information that it needs. So I'm just going to copy that for sake of saving some time. Excuse me. So we've got one object here for our source, but we also need another one for the destination. and I'm just going to say the rule, or I'm sorry, the description is stellar address of sender of receiver. Okay, so we take this. We're going to switch this back. Basically invert this and say JSON stringify that array. And then we need to B2A, turn that string into a base 64 string, and we pass that. That just allows us to pass this object to the turret. And then we're going to need a fee. This is not going to work because that's not the right fee, but it'll give us some information in the error that we need when we initially try to upload this. This is saying a fee payment with this hash has already been submitted. I think that's because I already have this contract uploaded. So I need to make it different, or I can actually go into my... So since this is my example contract, it's already been uploaded to my turret, and I actually want to show this upload working. So we could either change this contract in some way, or I could delete it from the system and upload it again. Which I'm honestly a little bit surprised, because I feel like these pieces that we added made it different. But maybe I never saved that change that I made previously. I don't know. I'm actually going to try and go into my dashboard over on this side on Cloudflare and manually remove this contract from my turret that I'm trying to upload this to. So give me one moment. Bear with me. But you know what? Let's actually, just because I'm curious, I want to make sure that this is, let's add a memo, because that'll make it for sure different, right? New memo. I don't actually remember the GS docs. I need to remember what the types are. Let's do text, memo text, new memo, hello world with the type of memo text, and I'm actually going to run this back through my run kit just to ensure that that actually still spits out an XDR, that the memo includes invalid memo type. Maybe you need to include the type before the string. Let's look up our memos here. Yep, you include the type and then the value. So I had that inverted. Try again. Okay, we've got a new XDR. Let's look it up on laboratory, make sure we've got our hello world. So now we've definitely changed it. So assuming we don't have some weird bug thing, we can paste that. That should have, yep, switch that, save that. Make sure we've got the right contract here. And we'll try and upload that again. Hopefully this... Oh, I'm dumb. I've already submitted this transaction. It's not telling me that the transaction function's already there. It's telling me that I've already used this transaction to pay for a transaction upload. So I need to make a new transaction. Exactly what you would expect. Apparently I didn't get enough sleep last night. Okay. Well, we want to build a transaction. We need to pay this turret this amount to upload this contract to this turret. So I have a testnet fee account that I already used. There's nothing special about it. You just create an account. Actually, I'll just do that now. What the heck? Create an account. Oops. get some funding for that. And then we will use this transaction, it's already on there, to make a payment to our turret. Got to pay the fees, pay our dues to get this contract up on the chain, on the network rather, loaded to this turret. And then we're going to get this signed. Don't submit. We need to actually use this hash, so don't submit that. The turret will submit it. Very important to ensure we don't get double payments or validate payments that have already been made. So now we send that to the turret. At least we'll have a memo now, which we didn't need. All right, so we've got our hash. I'm going to go save this in my notes over here. This will be the hash that we'll call for the turret and our all-important signer. So this is the signing key that we need to add to our controlled account, to our source account that we're trying to make those 1 lumen payments from. So we'll go to our account. It was that 3E4A account. Set our options. And again, this seems all very manual, but it's just a bunch of API calls that interfaces, GUI interfaces that hopefully people will build will make this process feel a lot less manual, because I'm just using Laboratory to do all this. All right, we need to add this signing key. We're going to give it the weight of 1. So our master has a weight of 1, but just to prove it, make sure, we'll give our master weight. We'll keep our master weight at 1. We will still have ownership over this account. I still want to have my account. I just want to open up access to it for the rest of the world to steal or take 1 lumen from me every time they make the call. Probably not a contract you'd actually want to upload. Maybe you would if you're feeling generous. You'll be able to give away 1 lumen until your funds run out. And then somebody else could give more, or you could just choose not to. A first come, first serve donation wallet. That's our smart contract. Okay, so we've uploaded that. Now we just need to sign for the control account, that source account that's giving the money away through the contract. So we submit that. Now if we were to look up our account on chain, you can see we've got 2 signers now, both with a weight of 1, and our thresholds are all 0. So now this turret key has control over this account, and people can access it through running this hash. How do you run a hash? How do you actually execute a smart contract? Well, we go to our TX function, run. Now there is an auth key. We'll get to this in just a second. I'm going to delete that just in case it's currently valid. Go to our parameters, put in our new XDR, and then we go over to our body, and our source should be that user account that we created. It could be, whatever you're getting from Albedo or Lobster or what have you, manual. And we submit that. This is going to throw an error that we don't have an auth token uploaded. So to be able to run contracts, you have to pay the turret a small fee. And we do that with a kind of a cell phone's minutes. Running contracts is actually very cheap. So we don't make individual 10 payments one at a time to a turret. We load it up with 1 to 10 lumens. And then as we call contracts, we use an authentication token to verify ourselves to withdraw funds from that sort of pool, if you will, those credit minutes, every time we make a TX function call. So I'm going to do that now. And that's where this fee, this doesn't need to be run right, so you'll load up minutes and be able to run for a nice long time, but we're going to need to add a new minutes to a fee accounter so we can get an auth token that allows us to run contracts. So I'm going to create another brand new, we'll actually use this one. So this is going to be our new fee account. So I'm going to build another transaction with our fee account. And this time we're going to make a payment just like we did when we uploaded a contract. I need to know this is the turret that we're paying. I'll pay 10 lumens to this. Go ahead and sign that. And just like we did before, don't submit it. We'll submit it in the body of our TX fee upload. There's a TX function fee right there. And the parameters is the like the fee account. This will be, you have to, whatever you upload here, whatever TX fee account that you use here, you need the signing key for this, because this is how you're going to generate authentication tokens. So I'm just going to use the same account that we used for this key, because I know I have the signing key and that makes sense. So I'm going to submit that. That will add those 10 lumens to this account, which now we have a balance of 10. So now we just need to authenticate the transaction against, whenever we run a contract, we need to authenticate against this fee account to say, use this account's balance that I have on this turret to pay for TX function runs. So for that, we need to generate an authentication token. There's quite a few different ways to do that. I'm going to show you this way. It's actually just a Stellar transaction. See if I can find one. Here we go. I'm going to put in this secret key. So this is the secret key that I was using for this. So because we need to sign it for the account that we're using, I need the signature for this, because this is the one we're using the minutes that we just uploaded, the credits that we just uploaded. So I need this secret key. This is what you would be running on your back end. If you're running this individually, if you're paying fees on behalf of users, you'll probably want this to be proxied on the back end somewhere to generate these authentication tokens. It's kind of like a JWT flow. And then there's a couple of different parameters. We could lock this down. We could lock this down to only allow this authentication to run on individual contracts. I'm actually going to do that so that if somebody got a hold of this, authentication token, they can only use it to run this TX function. And we could also set it to be single use, to where it can only be used one time. I'm going to leave that off so that this can be used multiple times. And then you can also set a kind of the valid, how long is this token valid for? If it's a single use, you have to set this to at or less than 1 hour, as well as probably including a memo hash. It's not enforced, but a memo hash allows this single-use token to be, the hash for it to be unique. Otherwise, you're going to run into issues with, hey, this has already been used, and because the XDR would be the same if you don't include some sort of variant. So that would be something you want to include if you're doing this as a single use, or maybe like some user token or something. I'm going to leave that on there just for the heck of it. And then we'll generate our authentication token. So you'll see the fee is set to 0. The sequence number will be 0. So this transaction actually can't get submitted, but it is signed. And that's the key part. It's been signed by this account, so we can prove that this authentication token has been signed by this account. Therefore, whoever uses it has the permission to use the funds in that particular account. So that when we go and we do our run, we'll put this in our bearer token. They'll be able to use that account's fees to run this. So we'll go ahead and make this run now. Did not include a destination address, so that's a helpful error. Destination. Nice thing about this particular contract is it's actually control account agnostic. You could upload this to any control account you want and use the same smart contract, because you're actually passing in the smart contract, or you're passing in the control account address as one of the arguments. So that's this key. This is the account that this contract has control over. But if you were to upload this signing key to different control accounts, you could use the exact same smart contract on multiple accounts. So that's kind of cool. Let's try and run this now. There we go. We got our XDR, which you'll notice if we look at it, not much has changed from the run kit. It's not signed or anything, but part of the data that was included was a signer and a signature, as well as the cost to actually generate this. You can see how infinitesimally small the amount of money that we spent against our fee balance, as well as the sponsor that we used, because we authenticated it with that token. And so all we need to do is take this XDR and add this signature And hopefully, if it's the right signature for this XDR, we can get it submitted. You'll notice, though, obviously, that this is not in any way decentralized. It's just a single turret. So this turret, if it got rogue, could just go find the secret key and start doing all kinds of stuff with my account. So we probably want to upload this contract to multiple turrets. And then instead of doing, remember where we did our build transaction and we did our set options, we probably want to include our thresholds. Maybe our master weight is 3. Well, let's do 2. And then each of these is 2 as well. So the master key can still sign for anything. But when we add hashes from our turrets, we're going to need 2 turrets, each adding their own signer. So no turret has complete control over the control account. It needs to act with some other turret, either the master key adding its final signature or another turret adding its final signature to get up to the threshold weight to be able to actually get a transaction using this account signed and submitted to chain. Right now, these are all 1, and this account is 1. So this turret technically has complete control over the account. So maybe not ideal, but again, it really illustrates the point that you get to build the decentralized model that makes sense for your contract. Again, assuming that when we add this signer with this signature to this XDR, whatever operations in this XDR, in this case, a payment from the destination to the source, actually gets submitted. So let's go ahead and do that. I've got a little handy run kit for doing that, which I'm going to have to find it in all of my mess of run kit notebooks. They haven't quite figured out the whole search thing. Here we go, add signature. So this is just a nice little widget. This you can do. I do this on the front end for my smart NFT thing, where it just pings all the turrets and then adds the signatures, assuming that the XDR is the same for all those, which it has to be for these signatures to be valid. So I just paste in this raw body. It's only going to be pulling the signer and signature and XDR from that, but it's easier just to paste in the whole object. Paste that or run that. It'll give me this XDR that now has the signature added. So if we were to submit this, you can see that we've got our signature added now. And if we submit this on chain, we get a transaction bad sequence. I wonder if we included the wrong source account. So this source account doesn't look like it's the same as that one. So it looks like we may have actually added the wrong destination address. Which one actually has our... This one is the one... This one's our user. This one's our signer. Interesting. Let me check this account and see if that actually has our signer on it. We're doing it live, folks. Oh, this one doesn't have the signers. Which one has the signers? Is it this one? I think I may have gotten my user and signature thing mixed up. Shoot, I could have sworn it was that one that I added it to. Who did I add? Did I get it mixed up with putting the... Bro, which one did I add the... I thought it was this one. So it looks like I didn't add the... Oh, there it is. This is the source account. I got mixed up. This is the source account. This is the user account. So I got my destination mixed up. This is the one that we're actually using as our control account, right? And this is the destination. This is the user that we want to pay, because this is the one that actually has the signature that's been added, this turret signature. So I got that mixed up. The nice thing is that it didn't submit because the signature doesn't match. So if we run this again, it'll generate the XDR that hopefully actually has the appropriate signature added to the right control account. I just got my addresses mixed up, which again illustrates that this actually only works if you get the right signature added, where the turret signer has actually been added to the control account you're actually trying to use. Let's try that all over again. And that should go through, where the control account loses that source account, loses a lumen, and the destination address gets a lumen. And it has 1001. So we've successfully executed our smart contract. I'm going to pause it there. That's fantastic, right? We've done so much. We've made our smart contract got it uploaded, got our fee, successfully executed the smart contract, got the XDR, added the signatures, and successfully executed a smart contract on Stellar without me having to enter the secret key of an account that I own. So it's all safe, secure, nice and tidy. As you have questions, now would be the time to start putting those in to either the Twitch chat again or the live chat in the Discord. I'm happy to answer any questions. If we want to, if we were to, just real quick while you're thinking of things you might have, if you wanted to upload this to multiple turrets, right? So if you wanted to put this on, say, the Script 3 turret, you'd have to follow that same process where you upload the contract to their turret, get a fee for their turret. The nice thing is you could actually use the same auth token. If you use the same fee source, you could pay 10 from the same account to my turret, 10 to the Script 3 turret, and then use the same authentication token on both turrets to actually make the call. So that's kind of nice little feature. And then for the signing keys that you would do that thing that I mentioned before, where maybe instead of having each one have full signing weight, you use weights and thresholds to where neither turret has full control, but if when acting together, you combine both of their signatures onto that XDR, so there are now 2 signers on the XDR from both of those turrets, that then has the sum weight of 2, which would be sufficient for that threshold if we were to set the threshold for that operation to 2. Hopefully that makes sense. Hopefully you're tracking with me. Any questions? I'm going to go ahead and switch back. We've been going for a nice long time here. Any questions? Kind of covered a lot, but should be enough material to kind of get the wheels turning. It's, again, really nice that you can build these smart contracts centralized. You're just building an XDR and then upload those to the turrets. Any questions? Doesn't look like it. I must have explained everything so well. Again, if you do have questions, Stellar, our Discord. I think I can paste links here in the chat. Let me create an invite to this really quick, just in case there's anybody here who does not have access or has not joined this Discord yet. That's the Stellar Turrets Discord that you'll want to jump into to find your feet, find your way around, and then obviously the landing page, tss.stellar.org. That's where you're going to find API documentation, the link to that reference implementation that I've been showing, all that good stuff. Otherwise, I think we're good there. It's time to go start making some smart contracts. Keep an eye on in the Stellar Discord. Follow me on Twitter, TYVDH. And it won't be too long. I'll be dropping the next smart NFT. I'm very excited about it. Should be a ton of fun. So keep an eye on it. It's a very exciting time, very exciting space to be able to build these decentralized smart contracts and get these transactions out there, committed, built, and signed in a decentralized way. Very excited. Otherwise, good luck. Thanks for joining, and I will catch you guys later.